So basically, counterfeiting is fraudulent and illegal activity, and counterfeiting can take many forms, right? It can take the form that, something that's relatively benign, where let's say someone fakes up a Gucci handbag and tries to sell it, pass it off as a real one. It can also take the form of something a little bit more serious and potentially life-threatening, where someone tries to introduce fake pills into the pharmaceutical supply chain. Probably the form that most everyone's familiar with is currency counterfeiting. Fake, suitcases of fake U.S. currency showing up on the market. There's hundreds of anti-counterfeiting technologies out on the market right now, but most of them are very narrowly limited to certain circumstances or certain applications, whereas ours can be made to fit the needs of many different applications.
So the microparticles that we're making are approximately the size of them is about the width of a human hair, to give you some dimension. And then when you zoom in on each one of these particles, it has individual stripes. And each one of these stripes has a different color to it. And so it's simply the combination of the number of colors and the arrangement of the stripes which gives the identity to the particle. So what we've actually done in this project is we've created a particle motif and then actually shown that we can manufacture these with extreme reproducibility, which is really important if you're going to put them into any commercial application, and then actually read them out with very low error rates. So we're not mistaking the identity of a code when we read it out of a blister pack or currency. And then another very important thing we wanted to do is to make sure that when we read them out, that you don't need $1 million machine to read out the particle, but it's something very small, compact, and economical. And what we've been able to achieve is just simply using iPhones or consumer phones to read these out.
So this is the prototype decoder that we developed as a lab scale. So this device consists of 3 parts, eyepiece, and then illumination part, and an objective. So we can easily attach iPhone to this device, and then we can see our particles.
Okay, so how would this actually work in practice? Let's assume you had some currency and you wanted to find out whether or not it was authentic. So what you'd do is you'd take the device, you'd put it down onto the currency, you'd shine an infrared light source in through here, the light would travel down, illuminate the particles, which would then emit visible light. That visible light would travel back up through the lens, and a picture of the particles would be displayed on the screen of your smartphone. This is a lab-scale device. One of our future goals is to reduce the size of this down to something that can very snugly fit on the top of your smartphone. In
the current state, these particles and the way we read them out are a very general platform for anti-counterfeiting. And the nice way about them is that we can add other modules onto them and tailor them for individual niche markets. So in pharmaceuticals, you may want to not only have the particles we currently have, but add on other sensors, and we can very easily do this. So I think what we're interested in the future is thinking about each one of these markets and how we tailor the particles to address the needs in the markets.